Now we are in part 5, the sine rule proof of the law of sine. We did the law of cosine, now it's the law of sine. Also, I'll explain how we got it before we have the formula. If I have any triangle, any scalene triangle, we know that if you have the height, if I take the triangle, for example, BDC, the sine of the angle, sine is opposite over hypotenuse. So it's h over a. So what's going to be the height? H, it's a sine c. If I take the other triangle ADB and I try to calculate the height, also sine A is opposite over hypotenuse is h over c. So h is sine c, c sine A. H is equal to h. It means a sine c is equal to c sine a. So I can write the ratio a over sine a is equal to c over sine c. And then I can do the same by drawing another height and I will get also equal to b sine b. Also, guys, you can switch it. You can write sine a over a is equal to sine c over c is equal to sine b over b. So every time I need to use the law of sine, three information should be given, or two sides and one angle, or two angle on one side, and then I can use it. But for the law of sine, we have also something very important here that we can use. It's called the ambiguous case of the sine rule. With they gave me those information that AB is 10, BC is 7, and BAC is 30 degrees. You can see that the angle that is given, it's not between the two sides that they gave it to me. For example, if you need to try to draw it, you will draw the side AB. Okay, excellent. I need the angle BAC is, I need it 30 degrees. I made a 30-degree angle, but where I gonna put C here? I don't know where I need to put it. But I know that BC is 7, so I know that BC should be somewhere here 7. And to be able to draw, to place the point B, you need to open your compass of 7 centimeter. You place the compass here and you need to draw a circle of radius 7. And when we draw the circle, for example, of radius 7, I'm not here accurate, the circle will cut the side in 2 points. So C could be here, either here. So I will not have one position for C. I have two possibilities for C. So I can construct two triangles ABC with BC7, AB10, and the angle here is 30. And those two angles, see that I have this one and this one, those are called supplementary angles. So those angles are supplementary. This is the case here. So if I want to understand what I'm doing here in this example, in this exercise, I will now do application in the on page 396. Find the unknown angle and side in the following triangle. So also I just did one part of that. So if I want to find the unknown angle or side, I have two angles are given on one side is given. So I have three information. So I can use the law of sine. The third angle, it's easy. I can find by doing 180 minus 30 plus 125. And then now to find the missing side, you can start from anywhere you want. You can start, for example, by AC over sine B is equal BC over sine 30. You find the values, you cross multiply, and then you will get AC is 10.3. Now I can write also AB over sine 25 is equal 10 over sine 30. You cross multiply and they will have AB is equal 8.45. And like this, I got the three sides and the three angles. Now, another example, before moving to the example that I said before, you will. Now here, a plane is flying from P to Q. So I have a plane needs to go like this directly. But something happened to this plane, okay? So uh, followed a course from P that had a 15-degree arc. So instead of going like this, the airplane went like this, and then it tried to fix her way, and then it went directly again to Q. So after traveling for 80 kilometers, the pilot corrected the course by changing direction at point R, flew a further 150 kilometers to reach Q. So instead of going directly from P to Q, he did this way and then this way. Assuming that the plane flew at a constant 400 kilometers per hour minus 1, how much time to the nearest second was lost due to the error? So instead of going straight, he did like this and like this. So instead of doing this distance, he did the distance 80 plus 150. So first step, I need to see what was the real distance that he should travel first. So I need to find PQ. To be able to find PQ, I need to use the law of sine shore. So I have PQ over sine R is equal 150 over, for example, sine 15. But do we have the angle R? We don't have the angle R. We don't have it. So first of all, so we need to find the angle R. The angle R. To be able to find the angle R, we need to find the angle Q first. So how are we going to find the angle Q using law of sine? I have sine Q over 80 is equal sine 15 over 150. I cross multiply and I will get the angle Q. Once I got Q 7.93, I can do now 180 minus 15 minus 7.93 and I will get the angle R 157.07. And now I can, once I have the angle, I can go here and do the sine, the law of sine. Then we replace and I can get PQ is 225.8 kilometers. So instead of doing 225.8 kilometers, what he did 80 plus 150, so he did 230 kilometers. And they said here that he did this by following 400 kilometers per hour. So he did 225.8 over 400 kilometer. So it means it took with him to travel this distance, or it will take with him to travel the real distance 0.5645 hours. But how much he really took to travel, it's 230 over 400, so he took with him 0.575 hours. They need the difference between in seconds. So first we need to subtract times 3600 to convert from hour to seconds. And then, so we see that the error was the loss of time exercise 3. From a hot air balloon, the angle of depreciation to each end of the lake are we have, so this is the balloon is here for the angle from the first for the end of the lake here is I have 32 degrees and the other angle is 68 degrees. Given that the balloon is 250 meters above the ground, when I say above the ground it means its height, it's perpendicular, so the height here EC is 250 meter. Find the length of the lake. I need to find AB here. This is the length of the lake. And I need to give my answer to the nearest meter. Excellent. So first of all, if I look at the information given here, I just have here it's 68 all this angle. Since this one is 32, it means this is 36. Here I have a Z shape alternating here, so this is 32, this is 32. And I can also have this angle here by doing 180 minus the sum of those two angles if I need it. Now, what is my objective? My objective, guys, is to find this distance AB. So first of all, I have the right triangle AEC. And in this right triangle, I can use tangent, for example, it's opposite over adjacent. I have EC, so I can find AC, all of it. But what I really need to find the small lengths here, so this one will help me to find, guys, when I subtract AC minus BC, I will have the length of the, what do we call the lake. Now, I got that the distance AC is 400.08 meter. I still need to find the small distance here. So to find it, I took the small right triangle EBC. And also, I know this is 68 degrees. So now, also tangent, it's opposite over adjacent. It's 250 over BC. Cross multiply, I got the small distance here. How are we going to find the real length of the gate? It's all this distance, 400.08 minus 108.0065, and then I will get that approximate length of the lake is 300 meter. We move to another exercise. Guys, I'm going a little bit fast just because I want to finish quickly. The diagram below shows 3 points A, B, C. It's very easy, guys, on level ground. A vertical mast MA stands. I have here it's standing like this. The top of the mast is supported by wires. I have two wires. The first one is MB and MC, and they gave me the angle. The objective is they need me to find MA, MB, and MC. So first, to find MC, I can see that if this angle is 64, I know that this is a 180 degrees, 180 degrees, sorry. So this one will be 116, 180 minus 64. Law of sine will give me Sine 116 over MC is equal sine 41. I took this angle over 15 because I cannot use sine 23. 23, I don't have the opposite side. And how do we find the 41? It's 180 minus 116 minus 23. I got MC. Now to find MB, I need also, I can use any other two angles and two sides. I can write sine 23 over MB because I need it. I can either use 116 and this side or 41 and 15. It's your choice. And then you're going to find MB is 8.92. And I still have to find AM. AM, I can find it either by doing sine opposite over hypotenuse, so katoa, or you can also use the law of sine. Sine 64 over AM is equal sine 90, I have it, over 8 point over MB, and then you will have the three measurements that they want me to find. I want to find AM, MB, and MC. The last exercise, this is what I was talking about. Show that two triangles ABC can be drawn such that AB is 31 centimeter, AC is 27, and ABC is 55. Find the size of the angles of each triangle. Give your answer to the nearest degree. So if you sketch it, as you see, the angle given is not between the two sides. Every time the angle given not between the two sides, so I'm talking about the ambiguous case of the sine rule. So I have BC, I don't have it. I don't have BC. I have BA is 31. I do it like this. Then when you do the angle 55, you don't know where to plot the point C. But from A, I need to draw a circle. Sure, it's not accurate. A circle of radius 27. And C can be either here or here. We first find this one, this C. And the other angle C, we're going to be 180 minus this angle. So first of all, I'm going to work in this triangle as I have 55, 31, 27. So I have it like this triangle one. 51, the angle I have here, 31, 27. So I can start by doing law of sine. Sine 50 over 27 is equal sine C over 31. This one will give me C. The angle C. Now to find the angle A, I can do 180 minus 55 minus 70, and I will get the angle A. Now, this angle is 70.13. The other angle C gonna be in triangle 2, 180 minus 70.13. So I'm gonna have another angle now. The other triangle, sorry, it's ABC. So I have it 31.55. This is 27, but the angle now is 109.87. And also I can find the third one, A, here by doing 180 minus the other two. And if I want to find the missing side, I can do law of sine. But if I don't need to find it, I just stop here. So this is 55, 109.87. Then I have to find the third angle A, 180 minus. And then I have the two triangles. Triangle 1 will be 55, 70.13, 54.87. And triangle 2 will be 55, 15.13, and 109.87. I'll re-explain again. So I have just one, I have two sides are given and an angle given not between the two sides. I don't remember if I mentioned when I was explaining in the beginning of the video. So when two sides are given and the angle not between the two sides, so I'm in the case of the ambiguous case of the sine. So in this case, the C could have two possibilities, because if I take my compass and I want to open 27, I'm gonna draw a circle, and the circle gonna got this side B in 2 points, so I have two C's. So, and those two C's, what's the relation between those two C's? They are supplementary. And then I found the first C, and then to find the other one, I do 180 minus the answer, and I will get the second case. That's it for this video. See you in the next video, guys.